This video is for section 14-4, the fundamental theorem of algebra. It's possible for a polynomial equation to have no real roots if you limit the roots to real numbers. For example, x squared equals -1 has no real roots. However, if the roots come from the set of complex numbers, then the equation would have two roots, right? You would take the positive and negative square root of both sides. The square root of -1 can be written using the symbol I, and so you get positive I or negative I. In 1799, the mathematician Carl Gauss proved that every polynomial equation has at least one root. Here's the modern version of his theorem. It's called the fundamental theorem of algebra. So one of the most important ideas from algebra. Every polynomial equation with degree n has exactly n complex roots. So a linear equation, which is degree 1, will have only one root. A quadratic equation, which is degree 2, will have two roots. A polynomial that goes to the 10th power is going to have 10 roots. So a really key idea in algebra. Here's an example. How many roots does this equation have? Well, what's its degree? The highest exponent anywhere in there is a 3. It's degree 3, so it has 3 roots. Now, what are the 3 roots? To actually find them, this is where you need to solve the equation. Or you could use the synthetic division process that we've been working on lately to find the roots. Let's try synthetic division. 1x cubed, 1x squared, 1x, and then 1 is the constant. And let's divide a number in there. Maybe -1 is a root. Bring down the 1. 1 times -1 is -1. These add up to 0. These times to 0, add these, multiply, and add these. -1 is a root. And by using synthetic division, we created a depressed equation. 1x squared plus 0x plus 1. And that depressed equation can be solved to find the other roots. We could subtract 1 from both sides, getting to here, and then take the positive and negative square root to find out that the other roots are plus or minus I. So it asks, what are they? One of them is -1. Another one is I, and another one is -I. There are the 3 roots. An equation can have a double root. What that means is that the same number can be a root twice. Let's solve this equation, not by synthetic division or anything, but just by traditional methods. For instance, maybe we might factor it as x minus 2 squared, and that's equal to 0. Then solve, and we see that x is equal to 2. But if we were to expand x minus 2 squared as x minus 2 times x minus 2, now we see why there's a double root. Because in the first factor, x is equal to 2, and in the second factor, x is also equal to 2. The number 2 is a root in 2 different factors. That's called a double root. Here's the theorem. If a polynomial equation with real coefficients has a root in this form, then its conjugate is also a root. Here's an example. If 2 roots of this equation are 1 and the square root of 2i, what must be another root? Well, whenever an equation has a complex root, something with the letter I in it, then its conjugate is also a root. That's what the last theorem said. So what's the conjugate of square root of 2i? It's negative square root of 2i. So the 3 roots are 1, square root of 2i, and negative square root of 2i. This says verify using regular or synthetic substitution. We've been doing a lot of synthetic substitution the past few days, so I'm going to verify this with regular substitution. Negative square root of 2i raised to the 3rd power minus, and then negative square root of 2i raised to the 2nd power plus 2, and then negative square root of 2i, and then minus 2. What we're wondering is, when we substitute that in place of x here and here and here, does it make 0? So let's find out. A negative to the third power is negative. The square root of 2 raised to the third power is 2 square root of 2. I to the third power makes negative I. Now here in this spot, a negative raised to the second power is positive. The square root of 2 raised to the second power is 2. And I to the second power is negative 1. Now we have a plus. 2 times negative square root of 2 makes negative 2 square root of 2i. And then there's the minus 2. Negative times negative makes 2 square root of 2i. Negative times negative makes positive 2. Then we have negative 2 square root of 2i and minus 2. Does this make 0? This term and this term are opposites and cancel, and this term and this term are opposites and cancel. So yes, this makes 0. We verified that negative square root of 2 times I is a root. Let's summarize the lesson. We discussed the fundamental theorem of algebra, which basically says that any polynomial equation will have as many roots as what the degree of the polynomial is. So if a polynomial is like x to the 5th power, there's going to be 5 roots. Now some of the roots might be real numbers and some of them might be imaginary numbers. If there is an imaginary root, this theorem here that's still on the screen says that conjugates are both going to be roots. Remember that you find roots by starting with synthetic division, and then once you've worked long enough to create a depressed equation that's quadratic, then you can solve that quadratic using other methods that you know.